The first question is explain what LiDAR data is and how it's created. Also how it is different from Lab 4. So LiDAR is an acronym for light detection and ranging. It is a remote sensing technology that uses laser pulses to collect X, Y, and Z coordinates, which then can be used to create a 3D model. You can detect features like road networks, bridges, vegetations. It is different from Lab 4 by having the extra Z coordinate. In Lab 4, we were limited to having only X, Y coordinates, which was our latitude and longitude. But with this data, we had the extra Z coordinate and you were able to create a 3D model. So the next question is to show the image that we were able to create, and this is it. You can see the bridges are right here, the buildings are right here, and then you can see the green kind of represents vegetation. The next is to show the transect that we had to take, the building. So this is the building, and it was 70 meters. And this is the actual building, like in real life. And this building is called the Guthrie Theater. So that should cover 4 and 5. Now 6 is explain what DEM and how it is different from LiDAR data. So DEM is an acronym for Digital Elevation Model. It is remote sensing technology that can be created from terrain's elevation data. Specifically, it is a raster data. It is usually made to represent the bare earth terrain, void of vegetation and man-made features. So this is really where it differs from LiDAR. You can create DEM with LiDAR data, but not the other way around. If you want to think of it as LiDAR and DEM being two separate steps, the first primary step is DEM that has like all the bare information, and then LiDAR is kind of like the elevated step where you get more than the bare minimum. Now show a 3D model of the lab that we created, of the buildings. So this is the model, and the red signifies the buildings right here, and you can see like the peaks and the valleys and like the water features. And the last question is to give a real life example of way you think that either of these two data sets could be useful for planning or research. So I decided to focus on LiDAR data. And a real life example I came up with was if the city wanted to mitigate stormwater with strategic tree planting, they would definitely use LiDAR data. So they would first use the data to get all the tree locations, so map it out in 3D, and then figure out which location would help the most to mitigate water. So in this way they could either take away trees or put in trees to control how the water would move. And that is it. Thank you.